All right, topic 2, bisectors and midpoints. So I'm actually going to jump for a second, I know this is a little weird, down to this box with new notation, kind of in the middle of the page. So if you can go to this box right here, this is what we're going to fill in right now. So we have this symbol, an equal sign with a squiggle on top. This symbol means congruent. And then definition of congruence, so two figures, so remember figures can mean lines, planes, segments, anything we get. Two figures are congruent if they are identical, if they are equal. So congruent is for pictures, images, lines, planes, segments. Equal is for numbers. So we could say 2 equals 2. X equals 5. So when we're talking about pictures, we use the congruent symbol. When we're talking about numbers, we use the equal symbol. So I just wanted to start with that before we fill in these notes on the top. So midpoint of a segment. If we have a segment AC and we place point B at the same distance from point A and from point C, then the two smaller segments are equal. So then AB, segment AB is congruent to segment BC, and then we could say the length of AB is equal to the length of BC. I also want to talk about these little markings here. This means congruent again, or the same. So because these two segments are the same length, we put these little dashes on it so we can look at the picture and kind of read the picture that the dashes tell us they're equal. So when the two sides are equal, then point B is called the midpoint because it's in the middle, exactly in the middle. All right, point B is also a bisector of segment AC because it is dividing the segment into two equal halves. So bisector, BI means two. Sect kind of means cut or break apart. So bisector breaks it into two equal parts. All right, then we already filled out that box. Now let's try some examples with some numbers. I know the notes can be a little trickier. A lot of times it makes more sense when we get numbers in there. So first thing, when I look at this, I see these little dashes. So these little dashes tell me that AB equals BC. So if this side is 6, well then this side is 6 because they're equal. So using our segment addition, AB plus BC equals AC. Well, 6 plus 6 equals AC. So 12 equals AC. And I know a lot of you could probably do that in a lot less steps than that. You do not have to show quite that many steps. I just want to make sure everyone understands how I got that 12. Ooh. All right, so example 2. Find ST if RT is 109. So once again, these little dashes tell us they're the same. All right, so let me just kind of move this. So it says that RT equals 109. So RT is from the beginning to the end. The whole line is 109. So if the whole line is 109, and then these little dashes tell me that the two sides are the same, well, then 109 divided by 2 is going to equal ST, because it's half. So 109 divided by 2, we get 54.5 equals ST. All right, next page. So I'm going to do these couple examples here, and then you're going to do a couple, and I will do the word problem again. So in each diagram, M is the midpoint of the segment. Find the indicated length. So because this is a midpoint, I'm not going to do segment addition. I'm going to do AM equals MB. I'm going to do that for both these pictures. So here, AM equals MB. So x plus 6 equals 3x. Subtract that x over. 6 equals 2x. Divide by 2. 3 equals x. Or you could say x equals 3. But now it wants us to find AM. So AM equals 3 plus 6. AM equals 9. Example 4. Find AB. So once again, the same AM equals MB. So I'm going to set them equal again. 6x plus 1 equals 9x minus 13. So minus 6x minus 6x. So I've got 11 equals 3x minus 13. I'm going to do plus 13. 24 equals 3x. I'm running out of room a little bit here. Let's see if we can go off the side. Here we go. So 24 equals 3x. Divide by 3. 8 equals x. So now they want us to find AB. So we need to plug in the x and see what we got. So I'm going to start with AM equals 6 times x, which is our 8, plus 11. AM equals 6 times 8 is 48, plus 11 is 59. Now, just to double check, I'm going to do MB. 9 times 8 minus 13. That 13 doesn't look good. 9 times 8 is 72. Minus 13 is 59. So if this half is 59 and this half is 59, the whole thing, AB, is 59 plus 59. And we get 118. All right. Now, on your own, I want you to try the two under here under you try, 1 and 2. Make sure not only to find x, but to plug in and find what they're asking for, the length of AB and the length of MB. When you're done with that, come back to the video and I'll do example 5 for us together. Example 5. You are walking on a path that lies along a straight road. The total length of the path is 7.2 kilometers. You have been walking for 48 minutes at an average speed of 4.8 kilometers per hour. How much farther in kilometers do you need to walk to reach the end of the path? So that was a lot of things happening there. So what we've got though, you are walking on a straight path. So I'm just going to start with a straight line, or as straight as I can get, a segment here. The total length is 7.2. So this whole thing is 7.2 kilometers. You have been walking for 48 minutes at an average speed of 4.8 kilometers per hour. So over here, I'm going to kind of set that up. You are somewhere on the line, but we need to find out exactly where that is. So we can do 4.8 kilometers in 1 hour, and we want that to be some unknown kilometers in 48 minutes. So as I look at this, something that we want to think about, we have hours and minutes, and that is not super helpful for us. So I'm going to change this 1 hour into 60 minutes. That's going to make our life a little bit easier because we have to have all our units match up. So now these two fractions are going to be equal, so we're going to be able to cross multiply. So grab your calculator, and when we cross multiply, we've got 4.8 times 48, so 230.4 equals 60x. Divide out that 60. And we get 3.84 kilometers equals our x. So you so far have walked 3.84 kilometers. How many more kilometers do you need to walk? I'm going to call that x again. It's a different x than before. So this goes all the way to the ends. The first part is 3.84. The second part is 7.2. So if we label our points here, we've got our segment addition from yesterday. AB plus BC equals AC. Plug in what we know. And then solve for, I guess I called this x, so let's call it x in our equation. Solve for x. 7.2 minus 3.84. We are at x equals 3.36. And there's our word problem. All right, thank you for getting your notes done. And if you're still finishing this in class and you have your checkpoint done, you may use the rest of the hour as free time. Thanks.